Hi everyone, this is our movie on measuring altitude, and what we know now is that we know that how these shadow plots are made, and that this little pointer right here, which was the gnomon, was casting shadows to this point, and those shadows, the point we made them, would look like this. At 10:16 we had a shadow that was that long. Okay? And since light travels in a straight line, it also kind of tells us where the sun was. It had to have been a straight path right behind that. Okay, so if we look at this from a side view, we can look at this gnomon, and as it was at 9:04, it was making a shadow from here to here. That's why we made a mark right there. We also know that from the toothpick shadows we did in class, that means that the shadow really, even though we can only see it on the ground, the line that defines that shadow comes in from the sun like this, and that's really making a triangular shadow. We did this on our last test. Well, because this makes a triangular shadow, this gives us a way to measure altitude and put a number on it. And all we need to do is measure this angle, and that's how we measure altitude in astronomy, is an arc of its angle off of the ground. And so we just have to know two things, and we can draw that shadow that this made exactly like it was when it was made on this shadow plot. We simply need to know the length of this base leg right here, and we need to know the height of the gnomon right there, which is written on all shadow plots. But those are the two things we need. If we have these two things, we can draw that triangle on a piece of paper, and we can measure this angle with total exactitude. So that's what we want to find. Well, if I go ahead and draw that triangle exactly like that, it's going to look like this. We measure the length of the shadow, and it was 4.5 centimeters long. So we know that that is going to be 4.5 centimeters. We have to measure it exactly. We also know the gnomon height is 2 centimeters, so now we know that that's 2 centimeters. And then finally, our altitude is just going to be measure of this angle, the one that is horizontally opposite from the right angle. And that gives us a very, very defined number for the altitude. So that is what you're going to be doing in the show. This would be measuring altitude worksheet that if you're watching this movie you would have missed. And again, this is just showing a little shadow triangle just like it's made on our shadow plots. And to find the altitude of that, we can just measure that angle. Now this one's all drawn for you. The light would be out this place someplace, so you just need to put your protractor on that angle, and you can find the altitude of that. And so on this one, you're just trying to find the altitude of the picture, and your protractor goes right there. Now, and then you can answer questions 2, 3, and 4, and then I'm going to have you do some more. It says, give the altitude of the following light sources, assume a 90-degree angle between the pole and the ground, and you'll need to draw out 7 triangles. If this case, the gnomon height was 5 centimeters and the shadow length was 7 centimeters, you will need to draw a triangle that has a base length of 7 centimeters, a height of 5 centimeters, and then measure the angle horizontally opposite the 90 degree, and that will give you the altitude. So on all of these, what you will need to do is draw out triangles. Here you're going to have to draw out 7 of them. You cannot find the altitude of a light source without drawing the triangle and without using a protractor. But the main idea on this is we now can use the shadows on our shadow plots to determine really exactly what the altitude of the sun was during that point of the day. And again, the altitude is basically the measure of the arc angle off the ground, which is exactly what you're finding with all of these, and like I just showed you on the PowerPoint. So go ahead and complete this paper, and we'll see you when you get back to class. Thanks for watching.